In question number 29, we need to draw the current voltage characteristic for the devices shown in figure 145E7 between the terminals A and B. So before we do that, we need to read this thing. In problems 25 to 30, assume that the resistance of each diode is 0 in forward bias and infinity in reverse bias. So what we will do is, in this question, on the x-axis we will apply a voltage at A with respect to B, and if the voltage at A with respect to B is more than 0, is positive, the diode is going to be forward biased and we will replace it with a 0 ohm resistor or a simple wire. And in that case, the voltage current relationship will be the same as the voltage current relationship across a 10 ohm resistor. When the voltage at A is negative with respect to B, this diode has infinite resistance and there will be no current on it, and that will be 0. So given these two facts, we can draw the current relationship something like this. This is the voltage V, which is the voltage of A with respect to B. If this is positive, the current I is like this. I is given by V by R, or V divided by 10 ohm. So when I is equal to, let's say, when V is equal to 1 volt, I is equal to 0.1 ampere. When V is equal to 2, this is going to be 0.2 ampere, and so on and so forth. And this is negative x-axis. When the voltage at A is negative with respect to B, there will be no current. So the curve looks like this. This is the first part, this one. Now in the second one, let's say A is positive and B is negative. When A is positive, this diode is forward biased, so the current starts flowing in this direction, and this one is reverse biased, so this is open and there is no current flow in this. So when A is positive and B is negative, the voltage current relationship looks like the same as this. But when B is positive and A is negative, and this one is reverse biased, so this one is open, but there is a path from here, because in that case the current will flow like this and this diode will be off. So the current will keep flowing in this direction when B is positive with respect to A. So in that case, the second case, the graph is going to look like this. This is voltage of A with respect to B, and this is current I. So when the A is positive with respect to B, the current will flow like this. When V is equal to 1, current will be 0.1 ampere. When V is equal to 2, the current is 0.2 ampere. And when B is positive with respect to A, so the current gets extended to this. So in this region, it will be, so in this region, from the B is positive with respect to A, or A is negative voltage with respect to B, the current will flow. The current is going to flow is this, so we call it as a negative current flowing in this direction. So this is the region when the current is flowing in this branch, and the values will be same because the resistances are both 10 ohms. So that solves this question number 29. Let's move on to question number 30. Find the equivalent resistance of the network shown in this figure. Take a closer look of this circuit. We need to find the equivalent resistance between A and B. What happens is, let's say when A is positive with respect to B. So when there are two cases in this circuit. depending upon whether the voltage A is positive with respect to B or A is negative with respect to C. If VA is greater than VB, then this diode is forward biased. When this diode is forward biased, this has a 0 ohm resistor. In that case, we have 10 ohm and 10 ohm are in parallel. So the circuit will looks like this. When VA is greater than VB, then the circuit looks like this. This 10 ohm and then 10 ohm are in parallel. This is point A and B. This is 10 ohm and this is 10 ohm. And in this case, R equivalent is equal to 5 ohm. The parallel of these two resistors is half of the resistance when VA is greater than VB. So the next case is when VA is less than VB. In that case, this diode D here is reversed biased because this is negative voltage, this is positive voltage, and this has infinite resistance, so this whole branch can be thought of to be open. In that case, the resistance between A and B is just this 10 ohm. So we write it as R equivalent is equal to 10 ohm when VA is less than VB, and in that case the equivalent circuit looks like this. A, this is B.